All right, so let's take this property of equality and actually apply it to some equations. So here's what we want to do. X plus 7 equals 18. We're trying to solve for x. And so the clearest way we can see that is that if we can get rid of this plus 7 and get x by itself, on the other side we'll have the answer. And so we're going to use the property of equality to do this. So right here, I can get rid of that plus 7 by just doing its opposite, subtracting 7. And this is okay to do, as long as what I do to one side of the equation, I do it to the other side. So on the other side of the equal sign, I'm going to also subtract 7. This keeps my equation balanced. And so when these cancel each other out, plus 7 and a minus 7, since they're opposite operations, I just get x. Equal sign drops down. And 18 minus 7 is 11. And then we can go back, check our work, stick in 11 for 7, and 11 plus 7 does equal 18. Okay. Now, here's another way to show that same work. I'm going to take the same problem, but here's a slightly different variation of showing your work for the property of equality. We know we're trying to get the plus 7 to just become 0. We want it to disappear. So what I can do is I'm just going to go ahead and cross that out. And then my next move will be to go to the other side and do its opposite, which is to subtract 7. It's essentially the same mathematics we're doing here. We're just showing it in a different way. So now I've got x equals, and then 18 minus 7 equals 11. And we already checked it, so we know it works. All right, so two different ways to show your work. Let's see that again on a different problem. Here's another one. 21 equals n minus 4. Now, this sometimes throws people because this time n, the variable we're solving for, is on the right side. But that doesn't matter. Okay, all we care about is we're trying to get n by itself. So I need to get rid of this minus 4. So once again, one way to show this work is to add 4 to this side. And what I do to one side of the equal sign, I do it to the other. Draw a line. Now over here, we intentionally did this because these are opposites and we'll just cancel each other out. We'll get n. Equal sign drops down, and 21 plus 4 is 25. Check our answer. 21 equals 25 minus 4. Plugging our answer back in, and 21 does equal 21. So that checks out. All right, so notice how it didn't matter that n was on the right side. We're just trying to get n by itself and solve for it. It doesn't matter with n's on the right or n's on the left. Now, if I want to show that the other way, same as before, I know I'm trying to get the minus 4 to become 0, so I just cross it out, and then I do the opposite move on the other side. So plus 4, which is 25, equals n, or n equals 25. Okay, now, here's one I chose because this sometimes trips people up. And the reason why is because of this minus and the negative. And the idea being that what we're trying to do here is the opposite operation. And sometimes people take this opposite piece too far. Okay, so for example, if I go back here the move was plus a positive 7. So we subtracted a positive 7. Notice how we did the opposite operation, but the number itself didn't change. It was positive 7 here, positive 7 here. Same thing on this last problem. We had minus 4, or minus positive 4, and we did plus positive 4. We did the opposite operation, but the 4 stayed positive 4. Okay, so we don't do anything any different here. Here it's g minus this number, so I'm going to do the opposite. I'm going to add that number. So notice how I did the opposite operation, but the number itself, even though it was negative, just stayed negative 4. What I do to one side, I do to the other side of the equal sign, and then I do my work. These cancel out. G drops down. Equal sign drops down. 10 plus negative 4 would turn out to be 6. And to check my answer, plug 6 back in. 6 minus negative 4 equals 10. Minus a negative is plus. And 6 plus 4, 10 equals 10. So it checks out. Okay. Now, here's another option for that problem. I'm sure a lot of you saw that from the beginning, we could have maybe made this a little easier, that this minus and negative can get confusing. And so before you actually start solving the problem, we could have done the trick where we do minus a negative is the same thing as plus a positive. Some of you from your previous teacher might have learned it as the keep, change, change trick, or the same, change, change trick. But it just means when you have minus and negative, it's the same thing as adding a positive. Okay, so now we get this. And now it's a lot easier to see what our move is here. It's g plus 4. We're going to subtract 4. What I do to one side, I do it to the other. These cancel out. I get g. and 10 minus 4 is 6. Same as what we got here, just done a little bit differently. So mainly here, just be careful with the negatives and the positives and the pluses and the minuses, and just realize that what we're doing here is the opposite of the operation, but not the opposite of the number.